We're looking for the smallest possible value of n. Now it could be that n is 7 digits, it's 1 million something. It could also be that n is 8 digits, it's 11 million something, or maybe 9 digits, 111 million something, or 110 million something, etc. But let's focus on 7-digit numbers, and if we can't find one, then we can move on to 8. So n is going to be some 7-digit number, so I'm going to leave 7 blanks here, and we're going to try and figure out what those digits are going to be. Now, we know that n is divisible by 33. That means it has to be divisible by both 3 and 11. Because it's divisible by 3, we know that the sum of its digits has to be a multiple of 3. But because it's built from zeros and ones, and there are only 7 digits, that means that the sum of the digits is either going to be 3 or 6. Just like we saw in the last problem, because the number is divisible by 11, if we take the sums of the alternating digits and we take their difference, that difference has to be divisible by 11. But we have only 7 digits, so even if they were all ones, that's only 7 in total. There's no possibility that this difference is going to be 11. That tells us that the difference has to be 0. And if the difference is 0, that tells us that each set of alternating digits has to have the same number of ones, and the only way for that to be possible is if there are 6 ones. Because if there's an odd number of ones, then the two sets can't have the same number of ones. So we know that we have 6 ones, but it's a 7-digit number, so that means we also have 1 0, and we need to figure out where that 0 is going to go. It can't be the first digit, because then our number would be less than 1 million, and we knew that the number has to be greater than 1 million, so that won't work. We also know that it can't be the second digit, because then if we look at the alternating sums of digits, if we start with the 1, we've got 1 plus 1 plus 1 plus 1, which is 4, and the other 0 plus 1 plus 1, which is 2. 4 minus 2 is 2. It's not a multiple of 11, so we know that this can't be it either. If we try the third digit, this ends up working. If you look at the alternating sums of digits, we've got 1 plus 0 plus 1 plus 1, which is 3. And we've got 1 plus 1 plus 1, which is 3. We know it's divisible by 11. We also know it's divisible by 3, because the sum of its digits is a multiple of 3. And this is the smallest possible number that fits, because if we moved the 0 any further to the right, we would end up with a larger number. Therefore, this is the smallest number that satisfies all of the given conditions. If we look at the first 4 digits, which is what we were asked for, we have 1101, and so we know that's answer choice D.